Hi everyone, my name is Amr Saeed. I am a mechanical engineer. I graduated from Alexandria University Mechanical Department in 2009. I am working in railway field like 6 years ago. To be more specific, in PSCD, platform screen doors, testing, commissioning, and also rolling stock testing, commissioning, and the interface between PSD, rolling stock, PSD, TCS, interface between some subsystems. When I started to work in PSD, I didn't find enough material to help me to start my career uh, comfortable. So I'm thinking to share with you my experience with PSD that may help my colleague to start their career in railway, or already the people they started their career in railway, maybe give them more details about PSD. I will start with the PSD system overview. Let me share with you this screen. Okay. We will talk about many things, I think, for testing, commissioning, for maintenance, for operation, maybe for requirements. We will see. Okay, PSD system overview. We will talk about three main topics: general description of PSD, main architecture, and controller and moving mechanism. General description of PSD system. We have to know the PSD system is composed of MSD, motorized sliding doors, EED, emergency exit doors, and this, as you see here in the video or in the PowerPoint, header box and the glazing. Glazing that means this glass. And the purpose of PSD to prevent people from falling onto track, to prevent accidents between people and the rolling stock, and also to keep the platform and the station cooled, to maintain the air conditioned platform or station. We have here like PSD system with full space wall up to ceiling. This like it's from ground to ceiling. And the other configuration, PSD system with tunnel envelope. As you see here, there is a roof of glazing with facade. We'll go in more depth and more details. Here in the project that I work on the Lucille project, LRT, light rail traffic, and you have here in the project 11 PSD system with 11 stations. 8 of them are tunnel envelope, as we saw before, this type, this configuration. And the 3 remaining is underground station with full space wall up from ground to the roof, from ground to the ceiling of the station. Here, another view of tunnel envelope PSD, and this is the ceiling one. And PSD system is steel structure, and PSD itself, and roof canopy and facade canopy. We will see this steel structure later in details, and we will go one by one. Here is like a functional presentation of PSD. As you see here in this diagram, you can see here MSD, EED, motorized sliding doors, emergency exit doors. This is driver indicator. with every PSD, MSD, and EED, you will find DCU, door control unit, till 12 door control unit. We have here sensors for motor and locked sensors. This is the power, main input power, and this is local control panel. We have here battery cabinet in case of losing the power, and we have MMS, master monitoring system, which monitors every movement of PSD system. We have here PSDCU, which totally control the PSD after receiving a signal from TCS, train control system. As you see here, this is another subsystem called train control system, which gives the platform screen doors control unit the signal to open or close the doors. This is driver control panel, which control MSD opening and closing. We'll see each component in much details. We have here MSD open. We need to understand how, even if you are working as testing and commissioning, you have to understand as much as you can the methodology of every component in your system. This is your responsibility. So here, when how MSD open, how motorized sliding doors open. When the train approach the platform and the correct docking, TCS, train control system, send a signal to PSDCU, which give this signal to DCU, this door control unit, which you can see here. This signal means the MSD should open their doors in synchronization with rolling stock doors. This operation is totally automatically. Totally, it's out of your hand. However, if there is any problem in the automatic operation, you can open or closing the MSD by 3 ways. You can open DCU, door control unit, and open the MSD, or you can open and close the MSD with local control panel, which is located on the platform, and also with driver control panel, which is located in the track side. So we have 3 manual ways to open MSD: DCU, LCB, DCB. And the closing, the same procedure. TCS send the signal to PSDCU, signal to DCU that MSD should close this automatically also, and to close the doors by DCU, LCB, DCB. Here, obstacle detection. As you see, this guy, he tried to open MSD manually, or he stuck in the way of closing of MSD. What happens in this case? You will find MSD open. How many times open? It depends on your system. Maybe 3, maybe 5. But the most important thing, it should open in synchronization with rolling stock doors. So if MSD, if rolling stock door opens for 3 times, if there is an obstacle, PSD should be open for 3 times, and the times depends on the amount of passengers, the headway, many factors. And we can see here in MMS the status of the door, which door is open, which door is closed, which door has obstacle detection. You will find here with this red signal, we will have a closer look on it. This interlock override you can set up, there is a mode called interlock override. You can set up this mode from LCP, local control panel. We use this interlock override when all doors of MACD or EED is not confirmed. So we need to, the train cannot leave or depart from the station without confirming that every door is closing and locking. However, if there is an issue with one door or many doors and we don't need to delay the train or make the headway more longer, we can use this mode interlock override to like send a signal that everything is okay, all doors closed and locked, and in this case the train can leave the station. You can notice here in MOM in the cabinet of PSD, it gives you an indication, visual indication about closing safety loop and locking safety loop, and the signals that send from MSD to TCS. You can see here some lamps off, some lamps on. You have to know which lamps is off and when it's off, and which lamps is on, and in which case, to know the status of the system. Here, if there is a system failure detection, how can we move the system? We said before we can control MSD by 3 ways: DCU, DCB, or LCB. Regarding DCB, you can control it from track side, LCB from platform side, and even if you are a passenger or maintainer, you can open MSD manually by release the manual device, as you see this guy in this this photo. And in any case of losing power, you can, this cabinet goes into service, this battery cabinet, and we can of course know that which door has a fault from MMS. This is driver indicator. This is visible signal generation. This driver indicator, it's totally green. When it's green, it's like all MSD EED are completely closed. When everything is okay, you will find it green. When some doors are open or isolated or has a fault, you will find it off. This driver indicator for the driver to see if everything is okay or not. For door open indicator, it's located, this driver indicator is located on the track. The only one who can see this driver indicator is the driver himself. But for door open indicator, it's installed on the header box on the platform side. And when everything is okay, means MSD, EED are closed, you will find this door open indicator is off. When anything is not okay, you will find it's like green. When it's isolated, you will find it red light. You will find it red light. Here you can see this MMS in closed view. This is configuration. There are here many parameters. You can see here this audible signal generation. When you are in technical room, you can hear like a beep sound of closing and opening of MMS. This is the first part, and the second part is main architecture and equipment. Main architecture and equipment. We will go into deep details. This is tunnel envelope configuration of PSD. As you see here, it's composed of two parts. The first one, steel structure, which supports PSD system and the glazing system, and the glazing system itself. This glass in facade and in the roof. You can see here this steel structure. It's very important to know how this steel structure is fixed, because you will make an inspection for installation, for testing, commissioning. So if there is any fault in the steel structure, it will be a huge problem for the whole system. As you see here, there are like many modules of many types of PSD. These types, you know, the difference between them, the length, the dimension, and the number of MSD and EED. For example, as you see here, this type A module, you can find it's like 7.8 meters. You'll find here 2 MSD and like 5 EED doors, and this is header box. You can find it. You can find another module 5.8 with less MSD, with less EED. You can find another module C with different, not in different dimension, but the order of MSD is different. Here in this drawing, it's here. In this drawing, it's here. Type D, type E, type F. Okay, this is the types of MSD and EED together. Every type of these doors has a header box. We will see the header box and what is the purpose of it. Header box has many moving parts of MSD, EED. All sensors are located in the header box, and it's covered by this cover, this header box, this one, to know the location of header box. In details, the inner components of header box, you can see it here. This is the drawing. This is the actual one on the side. You can find here DCU, a door control unit, which receives the signal from PSDCU to control the movement of MSD. This is a motor. When DCU receives signal for MSD to open, send the signal to motor. So motor starts to work in specific direction. This timing belt moves. This locking device unlock or lock if it's closing. You can see here pulley. You can see all these components are fixed on rail, on this rail. You can see here door hanger, which hang the door, and this door stopper, and the header box housing. This is the material. Someone asked me before about the material. What is the importance for me as test commissioning engineer to know the material of header box? Because when the material of PSD arrives to the site, you have to make material inspection and to confirm the material that arrived in the store or in the site is compliance with the approved material with the client. This is header box also, the drawing, the ceiling, header box rail, which installed in header box and hang every details, DCU motor, hanger, ruler, sensors, and this is the material, the size, the type of material, the type of rail, We saw before the type of type A, type B, type C. So the rail also has many types. Here it is, the motorized sliding doors, which is very important for very essential component. It composed of two double leaves, and it opens and closing when the tram correct docking in the station, and when the tram left the station. There is a specific key to open or close the MSD. We'll see it now. As you see here, this is type this key to open, just to open the header box cover. Okay. And this key to lock or unlock MSD, and this key for modes. PSD and MSD has 3 modes. We'll see it, I think. Okay, we'll see it later. This is the drawing of MSD. You can see here this silk print illuminated glass. Okay, this is another important component, which is emergency escape or emergency exit door, which is inserted between 2 motorized sliding doors. You can open it from the track side, from this panic bar in any emergency situation. And this is the specific material of AED. Here is the drawing of emergency escape door. We hear manual device handle, which uses to open AED from platform side, and this panic bar, which you can open the AED from track side. And this is illuminated glass, silk print, and this is door closer. It's very important to make sure this device is working smoothly without any delay, because it's responsible for the smooth of moving of the doors. This is a device which we are talking about. Okay. Very important, the material of this device, the reliability of this material to confirm that the door is opening and closing smoothly. And this is the threshold assembly, which you can see here, and this is interface between PSD and civil works. During your installation, you have to confirm that it's correctly installed. Any deviation from the design, it will affect the performance of the system. As you can see here, this threshold and this button guide to fix the door. You can see here in more details the installation of and the fixing of the door with threshold with the concrete. We have here insulate silicone. This insulation material is very important in the system to isolate PSD from the track, not from the track, from the ground, to prevent the electric current from moving from PSD to the ground itself, which may affect the passenger. Okay, the third part we have today, PSD system controller and the moving mechanism. Okay, we saw it before. This the component of header box. We can see it again. Here it is the rail, okay, the timing belt, which responsible for moving the MSD, DCU door control unit, this one which send a signal to the motor, which when it operates moves the time belt, and we have here also door hanger and the locking device and the stopper. We have to memorize every component of our system. This DCU controls the movement of PSD because it receives a command from DCU or from DCB or LCB. Here, the cabinet of PSD, the main brain of PSD system, which interfaces with TCS system and the SCADA system. It's composed of mainly two components, major component, MMS master monitoring system, which gives you visual information about PSD system, and also the interface between PSD and SCADA system. And also PSD control unit, as you see here, PSCCU A, PSCCU B, A and B. This is for redundancy. If there is an issue with PSCCU A, PSCCU B will work automatically, not to stop the system while operation. And the TCS send a signal to PSCCU to open or close PSD. Here we have local control panel system. One of the most important component of our system, local control panel, is located on the platform. Okay. Local control panel. It's located on the platform, and it has three modules, three modes. One of them, this is the normal, which is normal operation. But when you control LCB, when it's selected to normal, you cannot control anything because you cannot control your system automatically and manually at the same time, even automatically or manually, because you don't need to disturb the system or giving two orders automatically and manually. And this degraded mode, when something is when there is a fault, you can in degraded mode to control, to open and close the MSD. And you have here maintenance mode. Also, when it's maintenance mode, you cannot control MSD because maybe some maintainers are working in MSD. You cannot move the system while someone is stuck in the system for safety reasons. We have here driver control panel. This driver control panel, it's located in the track side for the driver to open or closing the MSD. We have here, as you see, just two modes. Here, three modes: normal, degraded, and the maintenance. But here, just normal and degraded. And the only one who can control and use DCB is the driver. He can plug one cable to DCB controller and moving and controlling MSD. This is in case of an emergency of something fault in the system. When he finish his control of MSD, he can unplug the cable from DCB. We have here door open indicator. You can see it in more details. This door open indicator, it's located on the platform side, gives you a hint of MSD status, and also EED. If it's normal, everything is okay, you will find here it's closed and locked. In normal mode, you can find it when it's everything is okay, the light is off. The light is off. When something fault, you can find it's green. When it's moving, you can find it light green color blinking. And when it's the mode of manual, you can find the same colors. When it's isolated, you will find it red. Isolated is very specific, very dangerous. You can it's temporary mode. You cannot leave PSD system with isolated for any door, because it's safety for passengers. Maybe one passenger can open the door while isolated and move and going into the track while tram is moving. This is driver indicator. For driver, it's located on the track. He can find it when everything is working normally. The red light is on. I think this is not okay. This green light should be green light. Yes, should be green light. And when if any doors is open, you can find it off. Also, you have battery mode. When it's in under control of battery mode, battery powered mode, you will find it the green light is blinking. This is looking device. We have here in more details the looking device of MSCD, and it explains here the schematic diagram for unlocking and locking the device by using DCU, DCB, LCB to DCU, which controls the locking device and motor driver, and for also locking device and vice versa. Here, more details, you can see here two sensors. You can find one sensor for safety loop and the other one for monitoring. For them, the sensors are activated when everything is okay. Means every door is closed and locked. This is magnet, and another one sensor. You can find one here in the header box and the other one in the door. Here in closer lock, you can find the sensor here in the header box. Also for EED, we have two switches, or if you can limit two sensors for safety loop and for monitoring of DCU, and these sensors are activated when EED is locked. This is power cabinet for PSD. You can find here some modules of AC/DC control, AC/DC converter module, and you can find here also the battery panel. In the operation of PSD system, we have 4 modes of the system and 3 modes of the MSCD. Let us look on the system modes. For the system mode, you can find it like normal, degraded, maintenance, and interlock override mode. For DCB, which is located on the track side, you can have just 2 modes, normal and degraded. For LCB, you can find maintenance, interlock, override mode, and also normal. For the priority, maintenance is priority, degraded is less priority. The lowest one is normal priority. the default for the system, of course, is normal mode. If we have a look here in for DCP, driver control panel, and local control panel, you can it shows here how you can select. For LCB, you can select the normal mode by moving it by specific key. And here for DCB, when you plugging the cable from the cabinet of rolling stock to DCB. When it's normal, it's unblocked. When it's normal here, it's normal. For degraded mode, here for DCB, you just the driver blocking the cable into the DCB and select from this key or from this switch or from this button the degraded mode. Here for LCB, you can control and select degraded mode by a specific key to degraded mode. When it's degraded, by the way, you can control opening and closing from DCB, LCB, the MSCD. We have here maintenance mode. It's only located on LCB, local control panel, because it's meaningless to have maintenance mode in DCB in the track side. Interlock override mode, it's located also in LCB when you want to override the closing and the locking of MSCD and the EED. Okay. For MSCD mode, we have 3 modes: normal mode, manual mode, and isolation mode. We can, of course, select any mode from a specific key in the platform. You can see here clearly the normal, isolation, and manual. Just in normal mode, the DCU receives a signal from PSDCU or LCB or DCB, and according to this signal, it's closed or opening for the MST. In manual mode, here in manual mode, you can control opening and closing of the door manually by the key. And also for isolation mode, you isolated the door and you override the locking and the closing of the door. Here in this operation under normal mode, see this clearer diagram. When the train approach platform and correct docking, door open, signal via what? TCS to PSDCU. And when it's correct docking, the door is open. Okay, clear? If there is everything is okay, MACD open, passenger in and out, no issue. Okay, if there is a failure in the automatic opening and the closing, opening for MACD, we can control and we can open MACD by using DCB. Driver control panel. The driver can, by selecting the graded mode and by plugging here the cable from the rolling stock to DCB, he can open the MSCD. And in the closing, the same signal from TCS to PSDCU to close MSCD. When it's everything is okay, MSCD will open. If there is an issue, the driver will connect DCB and control and closing the doors from DCB. Here, under the isolation mode, the authorized staff can select isolation mode to override closing or locking one of the door, and it's temporary mode. He has to repair this door as fast as he can. Operation under degraded degraded mode. When it's under degraded mode, for example, you can select here from LCB, local control panel. You can, after selecting, you can push short train or long train. What is the meaning of short train or long train? Our project here has a single unit, single vehicle, and a double vehicle. When it's a single vehicle, you can open just for specific MSD, not all MSD. When you have double vehicles, you have to open all doors, and this LCB transmit the open command to DCU. You can hear a sound for seconds, and DCU transmit the open command to the motor. After opening and closing, everything is okay. You will find the closed locked signal is turned off. Here also for LCB, the same procedure to close the doors. For DCB, same procedures, same methodology, blocking the cable to DCB and selecting the mode of degraded mode, and open for short train or long train, and the same procedures that DCB transmit the open command to DCU. As we mentioned before, after finishing your opening and the closing of MBCD, you have to disconnect DCB from DCB socket. For the operation of MACD, the EDD under mode, under interlock override, you can select override mode from LCB by using a specific key to just override there is a failure in one circuit, or there is an issue and you don't want to stop the movement of trains. You will select override mode till you fix the issue. When there is an issue with rolling stock itself, it should be proper docking on the station. Okay, what if the rolling stock is not correctly docking? The driver can let the passengers go out from the rolling stock and open for them PSD all doors for them manually by pushing the bar, or release the manual device for MACD. Okay. Under emergency, we have here, as you see, as we mentioned, this MACD. You can see here MACD release handle, and you can see here EED panic bar. After evacuation of passengers, you will find the doors closed automatically. They closed by the weight of the doors. Okay. For obstacle detection, we explained it before. For obstacle detection, it may be 3 times, 1 time, 2 times, 5 times, as you wish, and it's safety related, because you don't want for any passenger to be harmed from the doors. For LCB, you will find lamp button switch, or for DCB also the same, and you have to know how to connect DCB to the blogging or DCB socket. This is another photo of LCB located here in front module in the platform. It's clear, huh? Wow, it's a little bit long, but we have to explain as much as we can. This is a description of LCB. Every button, every switch, every mode of it. You can find here local control, and it turned when maintenance stuff using it. Local control. You see these yellow buttons. If only MSD EED are closed, you will find this button is green. And for short train, you will find it yellow. For long train, you will find this yellow. For interlock device, you will find it's activated here in the mode. Okay, if there is any failure in PSD, you will use this degraded mode. Maybe these faults, maybe unlocking of MCD or AD, or an issue in insulation, or battery problem, or PSCC issue. For this side, you can find push button, close all MSD. You can find it here. And for short train, for long train, you will find these indications is yellow. Also for interlock here, for interlock, yes, interlock here, and for lamp test. For DCB, as you see here, this is the driver. You can imagine here, this is a DCB with him here. He can connect it to this DCB socket when he approach to it, as you see here. This is DCB connector, and this is driver control panel itself. Also in details, the DCB local control panel, PSCD closed, PSCD failure. You can see these buttons here, and they will be activated when for local control panel. It will be yellow when you connect DCB. If every door is closed, you will find it green. If there is a failure, you will find it PSD failure. And you can close all the door by this switch. You can open for short train and for long train for this push button. For master monitoring system, MMS, we can find it here. This is the login view, and this is the main view. Of course, there is an ID with the password to have an access to the system. See here, system configuration, keyboard, system view, icon, information, and with everything, you will find just specific levels. For example, because you can control the system and change the methodology and the opening time, closing time, obstacle detection, reopening time from this MMS. So, for example, this is only level 3 user can access for system configuration. It depends on the importance of the configuration and the user himself. We have here level 2, 3, and with every level you will find it's like have an ID and password. And this icon information, it shows us TCS signal, operation mode, all door status, power status, error status, each door status. Here you can see here user ID, password. This is you see here this indication of isolation. Here this upper side for track upside. Here downside, you can find it written here, track upside, track downside. This is the status of every door. This is this DCU, and you can find here E48, this EED door, and you can find here M11 or M12, MSD. We have 12 MSD and 48 EED doors in our system here. What we have also, okay, this is levels, login, configuration. See, this is level 1, and it depends on your level. You can control and enter the login or configuration or report. You can notice it here, level 1, level 2, level 3. Okay, this is the system configuration, name of the station and the line and the IP address. Okay. Here is the details of the option you have. You can see here, so this is the very important TCS signal. For every indication, you have to know what this indication for. This is received closed signal from TCS, not received if you are talking about closed signal. If you are open signal short train, it's receiving or not receiving. For open signal long train, receiving or not receiving. This is TCS signal for closing and opening for short and long train. For operating mode, which mode you have? Normal mode, okay, it's green. Degraded mode, yellow. Red, maintenance. For interlock, you have to know interlock normal or interlock override. What is the door status for MSD and EED? If it's all are open, you can find it red. If it's closed and locked, you will find it green. If it's failed, you will find it yellow. And also for EED, if everything is okay, is green. Anything is open for EED, you will find it red. And power status, it's a normal power or UPS. For error status, PPS, this is cabinet, PSCDCU, another cabinet, DCU, door control unit, PIC, which is located on the platform, GVD. For every component here, you have the status. If it's normal, it's okay. If it's failure, you will find it the indication. For battery, for example, here battery failure, UPS, you will find it yellow. If it's the BPS itself failed, you will find it red, and all the same for every component. And for each door status, you can find each MSD. If it's closed and locked, MSD is green, not closed or locked, it's yellow. If there is an issue failure, you'll find it red. For modes, you'll find it M, manual mode, isolated mode, or there is a failure of CAN communication. Here you can find it obstacle and MSD reopen, and for EED the same. Description of it, you can find it here. PSCC A1 is working. We have also PSCC A2, PSCC P1, PSCC B2. This is the same for track downside, this track upside and track downside, and this is redundancy in case of a failure of any system. You will find if the other device is going into operation directly. This is system view also. You can find here, see log device status. This is open or close or fault. As we mentioned, the indication of every button. Here shows the status of individual device. You can see here, CAN communication, look one. What about the mode? Normal, degraded, maintenance, interlock, PSD, CU, short, open, or close. Here, auto close or open MCD. If there is a temperature failure, high temperature, you can find it here. here for the diagnosis of channels. Everything, if you understand and know the indication of it, you will find the error easily and fix it easily. This is the safety, the final paper we have, safety constraints and recommendations. Never open header box during crane operation. This is very important. For mode, you have to know the mode that you are working on. How for every device working, and you have to wear, if you are working as a maintainer, you have to wear insulation gloves not to be shocked. I think this is the end of first presentation, and we will continue in more details for our system PSD. Thank you guys, and see you again inshallah. Thank you.